Hello all, welcome back to my YouTube channel. Today we are going to see how to design a synchronous sequential circuit analysis. Now most of the time in the examinations you would get a questions like this: construct the excitation table, transition table, state table and state diagram for the sequential circuit shown below. They would give you a particular block diagram which would have flip-flops and a set of combination circuits. So how do we solve this? How do we write the state diagram for this particular circuit is what we are going to see. Now the first thing that we need to do is determine the flip-flop equations. Now we have Z, determine the equation for Z. Z is given by alpha into Q. So I'll write alpha into Q. Now we also need to know what is the input for the T flip-flop. So T is given by Z plus alpha bar into Q bar. Now we know that Z is nothing but alpha into Q. So I can also substitute T is equal to alpha Q plus alpha bar Q bar. I'll call this equation 1. Okay, this is the first step. Second step is to determine or derive the transition equations. Okay, the second step is to derive transition equation. So what's the transition equation? So knowing what is the equation to get the next stage, that is Q plus, we need to find or tell the equation for Q plus. Q plus is given by T XOR Q. Okay, this we will find from the characteristic equation of T flip-flop. Now next step is to substitute equation 1 in equation 2. Okay, substitute equation 1 in equation 2, you get the expression as Q plus is equal to alpha Q plus alpha bar Q bar XOR Q. I'll call this as equation 3. Fine. Till here what is that we have done is we have seen or we have derived the transition equation. Okay, the next step or the third step is to plot the transition table. The third step is to plot the transition table. So how do we write the transition table? Okay, third step, transition table. Now typically transition table is given by present state, next state and output. Fine. Now present state will determine for Q. Okay, next state will depend on alpha input. If alpha is equal to 0, if alpha is equal to 1, what will be my Q plus? Fine. Similarly my output Z will also depend on alpha. When alpha is equal to 0, alpha is equal to 1. Fine. Now when Q is 0, we have only one flip-flop, so I have only two combinations that is possible, either 0 or 1, either 0 or 1. What can I do? I can substitute Q value and alpha value in this equation and I can fill in this table. Say here for example, let us take Q is equal to 0, alpha is equal to 0. Okay, 0 into 0 is 0. Okay, so let me write it here, 0 and 0 plus 1 and 1 XOR 0. Right. Now 0 into 0 is 0 plus 1 XOR 0. 1 XOR 0 should give you 1. So I'll write this value of 1 here. Similarly, I will substitute for q is equal to 0 and alpha is equal to 1 from this equation. From this equation, I will get result to be 0. Similarly, for z from this equation, alpha into and q. So, 0 and 0 is 0, 0 and 1 is 0. Similarly, this will be 1 0, this will be 0 1. Fine. Now we have only one flip-flop and two possible outputs, that is 0 and 1. Now I will associate A, state A for 0 and state B for 1. Okay. From here, how do I write my state table? Okay. Fourth one, state table. Similarly, you will have present state, next state, output. This is a transition from this. Here we are written in zeros and ones, here we will represent in alphabets, that is all. So here again I will write for alpha is equal to 0, for alpha equal to 1, for alpha equal to 0, for alpha equal to 1. This will be my q plus, this will be my q plus z q. Okay. If I am in state A, and alpha equal to 0, okay, so 0 to 1, meaning I am going to state B. Okay. Similarly, if q is 0 and alpha is equal to 1, I am in state A, retain in state A. Similarly, for B, it is going to be B A, and the outputs will be represented as zeros and ones only. Fine. The final step here is to draw the state diagram. Okay, state diagram. So how many states we have? We have two states, A, B. Okay, you are in state A. If alpha is equal to 0, you go to state B and your output is 0. So you will write input slash output. Similarly, you are in state A. If alpha is equal to 1, you stay in the same state. So your input is 1, output is 0. Similarly, you are in state B and alpha is equal to 0, that is your input is equal to 0. What is your output? Output is also 0. Similarly, if alpha is equal to 1, from B you go to A and your input is 1, output is 1. Right. So this is how we write the state diagram for this particular problem. Thank you.